Hi everyone, it's Math with AUB. I forgot to write 4 of 23, frame 4 of 23. Let's embark upon our journey. Convert from kilometer per hour to meter per second. A simple sort of question. Kilometer per hour. We have to convert this one into meter per second. Meter per second. Kilo stands for thousand. 1 kilometer means 1000 meter, or 60 multiplied by 60. This 60 stands for minutes. This is 60 for stands for seconds. This 60 for minute, this for seconds. 6 the 36 007. So 1 hour comprising 3600 seconds. 1 kilometer comprising 1000 meters, while 1 hour comprising 3600 seconds. Let's see how to convert this one into meter per second. 1 multiplied by 1000. Per means divide. 3600. Double zero cancelled out. I have 10 over 33. 10 over 36. Applying table of 2. 5 over 18 meter per second. Meter per second. That is a magical figure. If you want to convert your unit from kilometer per hour to meter per second, just multiply by 5 upon 18. It is something additional to you. How to convert from kilometer per hour to meter per second? 1 kilometer is equal to 1000 meter. 1 kilometer is equal to 1000 meter. Kilo stands for 1000. While hour comprising 60 minutes and each minute consists of 60 seconds. So 60 into 60, 3600. 1 kilometer, 1 multiplied by 1000 divided by oblique divide per hour divided by 60 into 60 or 3600. One can do in that fashion. 64 minutes, 64 seconds. Calculation is almost same in that case. 10 over 36. Applying table of 2. We have 5 over 18. We have 5 over 18 meter per second. Meter per second. Okay, cool. Pass me the duster. Something different. Pass me the duster. Good. Moving towards question number 2, related to speed, time, distance, time, some sort of tiny questions of starting physics. A man takes 50 minutes for a journey if he runs at. Man qualifies for he, not for it. Okay, it's anyhow. I'm not here to deliver something on English. 50 minutes. Time is 50 minutes. Okay, cool. It runs at speed 48 kilometers per hour. Okay. The rate at which the train must a man takes, then the rate at which the train, oh my god, man, man must run to reduce the time to 40 minutes. 40 minutes will be first 50 minutes, speed is 48 kilometers per hour. From this too, we can manage the distance, but keeping this thing in mind, unit must be parallel. There is hour, there is minute, so 50 divided by 60, it will become 5 over 6 hours. 5 over 6 hours. First, we calculate how much distance the man has covered in 5 over 6 hours or in 50 minutes at the rate of 48 kilometers per hour. 48 kilometers per hour. So, physically, a man cannot run at 40 kilometers per hour. So, there is also a train. Let me sort out the data. A train. It is also a train. It's okay, don't you worry about this. Now it sounds to me good. So train takes 50 minutes. How long, how much distance it has covered at the speed of 48 kilometers per hour? Speed is given to us, time is given to us, making the units parallel. Parallel R, there is minute, we have converted minutes to R, it's good. Distance is given by, distance is equal to speed times time. Speed times time. So I have a speed 48 and time is 5 over 6. Applying table of 6, 6 8 the 48. 6 is the 36, 6 8 the 48. So we have distance covered by the train in 50 minutes or 5 or 6 hours is 8 5 the 40 kilometers. 40 kilometers. Now, second part. Now, safely we have the distance. We have the distance. What we have to manage? We have to find the next rate at which the train must run to reduce the time from 50 minutes to 40 minutes. From 50 minutes to 40 minutes. Now, our time must be consumed 40 minutes. Okay, converting time into hour, 40 divided by 60, it will become 2 over 3, 0, 0 cancel, applying table of 2. Distance we have already managed, 40 kilometers. Distance is 40 kilometers. Now we have to find the speed at which the train must run in order to save 10 minutes. 10 minutes. Cover the same distance, cover the 40 kilometers, not in 50 minutes, now in 40 minutes. Instead of 50, 40 minutes to save 10 minutes from 5 over 6 to 2 upon 3 hours. Same formula, distance is equal to speed multiplied by time. Distance is 40. We are interested in speed. Time is 2 over 3. Solve for speed. 3 will be in multiplication, 2 is in division. So I have 40 times 3 divided by 2. So the distance is 2 times 20 into 3. Sorry, speed is 60 kilometers per hour. Our train initially running at 48 kilometers per hour for first 50 minutes. Utilizing these two facts, converting minutes into hours, I have utilized both this time and speed to get to distance. I have distance. Now, same distance we have to cover. We have to save some 10 minutes from 50 minutes to 40 minutes. Covering distance must be same, that is 40. We are interested in the speed that saves us 10 minutes from 50 to 40 minutes, or it takes only 40 minutes. I have converted again 40 minutes into hour dividing by 60. Distance I have already calculated. Same formula. Distance is equal to speed times time. Distance is 40. S stands for speed into 2 over 3. And then I have solved for speed, that is 60 kilometers per hour. That's our option D in that case. Moving towards next question, it is of the same sort. The air is human, to forgive is divine. Instead of 10, my people have written at one place man, at the other place trend. It is maintainable. I have managed. Second one seems to me, a man takes 50 minutes to cover a certain distance at a speed of 6 kilometers per hour. If he walks with a speed of 10 kilometers per hour, I have no idea. Let's see and find out. 50 minutes, first 50 minutes, it runs at the speed of 6 kilometers per hour. If he walks with a speed of 10 kilometers per hour, he covers the same distance in what time? First, I have time 50 minutes. 50 minutes. Okay, cool. Here, and the speed of the man is 6 kilometers per hour. 6 kilometers. Look at this. That's 50 minutes. That's a converting minute to hour by dividing 60. I have 5 over 6 hours. 5 or 6. Let's calculate the distance. Distance is equal to speed times time. Speed times time. Distance is speed 6 and the distance is, time is, speed is 6 and time is 5 over 6. 6, 6 cancelled now. So our distance is 5 kilometer. Distance is 5 kilometer. Now, if the man runs at 10 kilometer per hour, 10 kilometer per hour, it covers the same distance in how much time? Distances are 5 kilometer. Speed is given to us 10 kilometer. Now new speed is 10 kilometers. 10 kilometers, sorry. 10 kilometers per hour. 10 kilometers per hour. Same. We have to find time. So distance is given by speed times time. Distance is same 5 in both the cases. Speed has changed from 6 to 10. We are interested in time. Shift 10 here. It will become 5 over 10 is equal to t. 1 upon 2 or 1 upon 2 or converting this into minute by multiplying 60, it is equal to 30 minutes. 30 minutes. If your answer is greater than hours, then it is you're going to be answer. Here 30 minutes or half hour, they are same. 1 upon 2 hours or 30 minutes. 1 upon 2 hours or 30 minutes, they are same. First 50 minutes and 6 kilometers, utilizing these two, we have arrived at the distance. We have found out the distance. Then utilizing the same distance, we are asked the man covered the same distance in what time, running at the speed of 10 kilometers. First we have time and speed, we have managed distance. Utilizing the fact that there is minute, there is hour, unit must be parallel. Unit must be parallel. I have converted minutes into hours by dividing 60. That's our this one. And second speed of the man is 10 kilometers per hour. He has to cover same 5 kilometers in what time? In what time? Distance is 5, speed is 10. Solve 40, 5 over 10 means 1 over 2. Half hour or 30 minutes is the answer in that case. Cool. Moving towards question number 4. Question number 4. It some sort of percent question. Mixed Sunday branch. Mixed branch is a good branch for people to learn, especially in the final phase of the examination. As the time drawing closer, you should work with variety, rather than topic by topic. Just mix a Sunday branch type of question. Without okay. Question number 4. The price of an article is decreased by 10%. To restore it to its former actual value, the new price must be increased by, here it is a decrease, normally 100%. 10 is decreased, that is 90. Now we are interested how much percent of 90 is equal to 10, because we have to restore again 10, not 10%, 10. We have to calculate from 100, we have been thrown at 90, at 90. From 90 again we have to restore to 100, 200. What is the percent of 90? That is equal to 110. What is the percentage of 90? That is equal to 10. That is restored in that 90 to get 100 again. Means what percent of simply 90 is 10? Because we have to add 10 in this 90, 10 in this 90. We have just concluded that 10% of 100 is 10. 10% of 100 is 10. Mark my words. 10% of 90 is not 10. 10% of 90 is not 9. Keep this thing in mind. Okay. Solving for x, 90. To remove percent, divide by 100. I have 10. Cancelled out. 0, 0. I have 9x over 10 is equal to 100. Shift this thing here. So x is equal to 10 times 10 divided by 9. It will become 100 over 9. 100 over 9. Applying table. Simply divide 100 over 9. That is the beauty of quantitative mathematics, that you have to use no calculator. 1 9 the 9, subtract 1 0 again 1 9 the 9, 2 9 the 18, it grow bigger. So keep it simple. 1 times 9 is 9. Here I have 1 again. So that is my quotient, that's my remainder, that's my divider. How to write this one? Quotient remainder over divisor. Table has been applied of 9 11 times. 11 whole 1 upon 9, 11 whole 1 upon 9, 11 whole 1 upon 9. If we take the 11 whole 1 upon 9% of this 90, 11 whole 1 over 9, 11 whole 1 over 9% of 90 is equal to 10. One can verify this as well. Let me make some space. X is 11 whole 1 upon 9%. Okay. 9 11 the 99 will become 100. 90 9 11 the 99 plus 100 over 90. Applying table of 9, 10 times. Now dividing by 100 in order to remove percent. 00 cancelled, so there is 10, there is 10. That is the percent we have to restore, means 11 whole 1 upon 9% of the 90. 11 whole 1 upon 9% of the 90 is required to restore 90 to again 100, from 90 to 100 again, 90 to 100 again. 10% of 100 is 10, while 11 whole 1 upon 9% of 90 is equal to 10, is equal to 10, because 10% of the greater quantity results in greater and 10% of smaller quantity results smaller. That's why 10% of 100 is equal to 11 whole 1 upon 9% of the 90. They both equal then 10. 10% of 100 is equal to 10, and then 11 whole 1 upon 9% of 90 is equal to 10. Means smaller quantity has to pay off much in order to compete with the greater quantity. Okay. Moving towards, so our right option is 11 whole, 11 whole, 1 upon 9 in that case. Final question, that is based on two parallel lines cutting a transversal, really very easy by virtue of tiny things in geometry, but a good one as well. Let's see. I have here is x and here it is 110. It is 110. By virtue of alternate angle, it is also equal to 110. It is also equal to 110 by virtue of alternate angles. Okay. Then this linear pair is equal to 180. Then this linear pair is equal to 180. Means 110 plus x is equal to 180. Because the straight line measures 180. Solve for x, it is equal to 180 minus 110. X is equal to, in that case, 70, I think. X is 70. Or one can take another different approach in that case. Here is 110. Here is x. By virtue of corresponding angles, it is also equal to 110. Same 110 plus x, it is equal to 180. Solve for x, again it is 70. Again it is 70. Or by virtue of corresponding angles, it is also x. It's also sum of linear pair or straight line measures 180. 110 plus x is equal to 180. Again we are going to have same answer. In that case, value of x is 70. Value of x is 70. By virtue of corresponding angles, it is also 110. Okay, 110 plus 70 is equal to 180. By virtue of alternate angles, it is 110. It is also 110. This is also a linear pair. Again, x results in the same. Or this is x. By virtue of vertical angle, it is also equal to x. This is also equal to 180. Whatever suits you, just do that. You should have familiarity. What do you mean by vertical angles? What do you mean by corresponding angles? What do you mean by alternate angles? Okay, cool. That is frame number 4 of 23 for the direct preparation of IBA phase 2. It's all by itself. Next.